Start.
Sir,
Yeah, start. I'm just seeing. It's okay.
good morning everyone. So the topic that I'll be teaching today is about total copper loss due to bar current and end ring current. So bar current in the rotor of a squirrel cage induction motor can be determined by comparing the MMF in both rotor and stator. So the current per rotor bar is given as IB equal to KWS into SS into ZS into IR divided by KWR into SR into ZR. So, where KWS is winding factor of stator, SS is number of stator slots, ZS is number of conductors per stator slots, KWR is winding factor of rotor, SR is number of rotor slots, ZR is number of conductors per rotor slots, and IR is equivalent rotor current, which is given as IR equal to 0.85 IS, where IS is stator current per phase. So, length of rotor bar LB is L plus allowance for skewing. So, skewing is like we skew the rotor slots at some angle, so the bars lie under alternative harmonic poles. Skewing is done to prevent crawling. Crawling means running induction motor at very low speed, so we are considering that also. The rotor bar resistance is 0.021 into LB by AB. So AB is cross sectional area of rotor bars, which is given as IB by delta B millimeter square. Delta B is the current density of rotor bar, which is assumed between 4 to 7 amp per millimeter square. So the copper loss in rotor bars is given as IB square into RB, that is resistance of rotor bar, into number of rotor bars. So coming to end rings, so in this figure we can see the end rings are short circuited to the rotor bars are short circuited to the end rings. So these bars here are rotor bars, and these two here at the top are the end rings. So rotor bars are short circuited by connecting them to end rings at both the sides. So the here rotating magnetic field is produced, which will induce an EMF. So since the rotor is short circuited, there will be current flow here due to the induced EMF. So we can see that the current flow is sinusoidal. In the figure, we can see the distribution of current and end rings. So, and the bars are under one pole pitch. So, half of the number of bars and the end ring will carry the current in one direction, and the other will carry in the opposite direction. So, the maximum end ring current is taken as a sum of average current in half of number of bars under one pole. So the maximum end ring current IE max is given as number of rotor bars per pole divided by 2 into current per rotor bar. IE max is equal to SR by P whole divided by 2 into IB average, and IB average is given as 2 by pi I max. So hence the final equation will be half into SR by P into IB by 1.11, 1.11. So hence the RMS value of I is 1 divided by 2 root 2 into SR by P into IB divided by 1.11, or we can write it as 1 by pi into SR by P into IB divided by 1.11. Mean diameter of end ring DME is assumed to be 4 to 6 centimeters, which is less than the rotor. Mean length of the current path in end ring is given as LME equal to pi DME. DME is mean diameter of end ring. The resistance of end ring RE is 0.021 into LME divided by AE. A is the area of each end ring, uh, which is IE divided by current density. Current density is assumed as 4.5 to 7.5 amp per millimeter square. Uh, Thus, the total copper loss in end ring is 2 into I square into RE. Yes,
You
sir.
have, yeah, yeah, but you have not written that expression for the total copper loss, na? You have just given the separately two things. Then you have to add it up, na? Finally, one slide is missing in this. Anyways, who's second? Yeah, yesterday Bhavna. Yeah, yeah,
Manohar.
Manohar. Yes.
Magnetism.
Yeah, yeah. Start with yours.
Okay, so
Okay.
good morning to everyone. Today I'm going to explain about the magnetizing current of induction motor. That is nothing no load current of induction motor. I'm going to derive the magnetization current. So first of all, so no load current of for the use for the design of induction motors. No load current, as we know, it has two components. One is the magnetizing component, and other one is iron loss component. The phase relation between these both is given in the figure down. That is figure 14. Thus, the no load current from these two is equals to I naught is equals to square root of magnetizing current plus that is the iron loss component IW the square amperes. Here you can see that the magnetizing current is 90-degree away from the lagging from the voltage, and IL is in phase with voltage. So now coming to the magnetizing current, the magnetizing current of induction motor, it is responsible for producing the required amount of flux that is in the different parts of the machine. Hence, this current can be calculated from all the magnetic parts, parts of the machine, which also includes the ampere turns for all the magnetic circuits such as stator core, stator teeth, air gap, rotor core, rotor teeth, and which gives the total ampere turns required for the magnetic circuit. Here is the equation given, that is magnetizing current Im is equals to P, that is poles, number of pair of poles, 80/30, that is total ampere turns of the magnetic circuit at 300 from the center of the pole. T phase, that is number of stator turns per phase, and Kw is the winding factor. Next component, the iron loss component of current. This component of current is responsible for supplying the iron losses in the magnetic circuit. Hence, this component can be calculated from no load losses and applied voltage. The equation for iron loss component of current is IW is equals to total no load losses by 3 times into phase voltage. So the final no load power factor of induction motor is very poor. As the load on the machine increases, the power factor improves. No load power factor can be calculated knowing the components of no load current. So no load current power factor cos phi naught is equals to IW naught. So one of the magnetizing component, the one of the
Manohar, we cannot
four
hear
main
properly. Manohar, I can after
Okay.
I'm not able to. Yeah, yeah. Please speak near to the mic.
Uh, to find the flow through a
I think some problem with your network, huh, Manohar? We're not able to hear you. We are not able to hear. Yeah, yeah. We are not able to hear.
now, sir.
Now, yes.
Hello.
Now we can hear. Yeah, yeah. Now we can hear.
Shall I continue with the derivation or start from the first? Hello.
Now we can hear. Continue, continue.
Okay.
Okay.
To find magnetic current, it is required to estimate the ampere turns required to pass flux through the magnetic path. So the magnetic flux flows through the following parts of the induction motor, that is stator core, stator teeth, air gap, rotor teeth, and rotor core. In stator and rotor teeth, flux density distribution is approximated as a sine wave with a superimposed third harmonic as a flux density distributed. The value of flux densities at 60 degree from the interpole axes is the same irrespective of whether the third harmonic is present, and it is 30 degree from the polar axis. So the mmf in various parts is determined as follows. The mmf for air gap, the flux density at 60 degree from the interpole axis is given by bg, that is 60 degree because b average into sine 60 degree, that is the magnetic flux average into sine 60 degree, which is a sine wave. We know BAV is equals to 5 by A, and it is and sine wave pi by 2 into root 3 by 2, which is given as 1.36 into BAV, and 80 ampere turn for air gap is 80,000 BAG 60 degree in kg into Ig, where kg is the Carter's coefficient. Next, we have MMF for stator path. The parallel side teeth. The flux density is uniform throughout the height of the teeth, as we know, and the taper teeth. Since the flux density can be determined by finding the flux density at one third height of the tooth from the narrow end, and the flux density at one third height is dts by 1 by 3 is equals to 5 m by ss, that is stator slots by poles into this into wt, which is given as 1.36 in bts 1 by 3, one third of the height, flux density at one third of the height. Then mmf for stator teeth. The mmf calculation for the rotor teeth is similar to that of the stator teeth, which is given by 5 by m, or it can be like mmf per meter length into diameter of the stator teeth. That is given 1.36 btr 1 by third. And mmf for stator core, it is given by the mmf per turn length of the stator core into length of the flux path in stator core. The flux density in the stator core BCS, the ampere turns per length at ATS, is found from BH curve of the material. The length of the flux path for stator core is the core diameter. That is ICS is equals to 1 by third of the pole pitch at mean diameter, which is given by pi into D plus 2 ds plus DCS by P. Next is the MMF of rotor core. This is similar to the stator core and is given by the one third into pole pitch at mean diameter. Therefore, the total magnetizing MMF per pole is given by ATG, that is at MF required for air gap into MMF required for stator teeth plus MMF required at rotor teeth plus MMF for stator rotor teeth, and the magnetizing current is given by total MMF by number of turns, that is AT, total number of turns by number of total mmf by number of turns t. RMS value of Im is equals to AT by root 2, and the peak mmf related to RMS value of Im is 2.7 Im I phase into T phase into winding factor by poles, that is ampere turns per pole, where P is equals to number of poles and T phase is number of turns per poles, and Kw is equals to winding factor. When you substitute in the formula for magnetizing current, we get P, that is number of poles, 80 30 ampere turns at 30 degree, 2.7 into winding factor in T phase into sine 60 degree, which in turn we get sin 60 is root 3 by 2, that is pt3 that it by 2.34 kW into t phase. This is the expression for magnetizing current of the induction motor. Thank you.
Third person. Yeah,
Yes, sir.
yeah. Start. Yeah, Ajit Kumar. Maximize it. We cannot see it actually. Yeah, it's very small. You cannot maximize it more than this. Like full screen. Okay. Yeah, now it's full screen. Now it's looking good. Yeah, you can start. You, I think your voice is muted, so please open this thing, your voice, and start. Ajit Kumar, I cannot hear you. Yeah,
Yes, now, sir.
now we can hear. Yes, start. Go for it.
So, good morning. So, today I'm going to start discuss rotor bar current and entering current. So, half of my portion was discussed by Bhavana. So, I'm going to brush it up today. So, to find bar current, uh, so the bar current is determined by comparing rotor current and by comparing MMF developed in rotor and stator. So the rotor current MMF is equal to 85% of stator MMF. So the number of rotor, let us assume number of rotor bar NB is equal to SR, which is number of rotor slots. So IB, let IB be rotor bar current. So to find rotor MMF, we know that rotor MMF equal to IB into NB divided by 2. So NB is equal to SR. So therefore, rotor MMF will be equal to IB into SR divided by 2. So we are using squirrel cage induction motor. So in squirrel cage induction motor, um, we are going to assume that polyphase winding with SR bar and they can be assumed to be connected in phase. So the pole pitch apart from, will be SR by two phases with one turn each. So stator MMF equal will be equal to 3 into I phase into T phase. So from the above equation, rotor MMF equal to 0.85 into stator MMF. So when we substitute rotor MMF and stator MMF, IB by SR, IB into SR divided by 2 equal to 0.85 into 3 into I phase into T phase. So from this equation we can find bar current. So IB equal to 0.85 into 6 into I phase into T phase divided by SR. So the next topic is entering current. So the entering current, the all the rotor bars are short circuited by connecting them to the entering to the at both the entering, as we can see in this image. So these are the bars and above bar and below bar are the enterings. So the rotating magnetic field produces induced EMF, which will be in sinusoidal form over one pole pitch. As the as the rotor is short circuited, short circuited, so there will be a current flow because of EMF induced. So the distribution of EMF is shown in the figure below. So referring this figure, um, bars under one pole, considering the bars under one pole pitch and half of the number of bars and the end ring carry the current in one direction and the other half is in the opposite direction. So thus maximum end ring current may be taken as the sum of the average current in half of the number of bars under one pole. So to find maximum value of entering current, IE max equal to average current divided by bar into number of bars over half a pole pitch. So average current by bar is equal to 2 by pi into IB max into SR by 2 pi. So which maximum value of entering current will be equal to SR into IB max divided by pi into P. So 2 will be cancelled. So this is the final equation. So to find the RMS value of entering current, bar current, so we know that IB is equal to IB max by root 2. So when we substitute this IB max in a maximum value of entering current, so IE max will be equal to SR into IB into 2 divided by pi p. So thank you.
All of you did very well to explain, especially Bhavna. You put in effort. So, and then Manohar also, you have put in effort. Ajit Kumar, you also. So, today, what I will like, if I have to rate, see, because you have to give some rating for everyone. So, although it's very nearby, but I'll rate Manohar number two, Bhavna number one, and Ajit Kumar number three. So, it's not because of the presentation, it's about the other factors also, the explanation, the way you are doing it. So this is why it brings the flip class. So Bhavna, what was your experience after giving the flip class? Did it improve something? Bhavna,
Yes,
Bhavna,
sir.
what
Yes, sir.
happened? Happened after you can just finish your flip class? Please share your experience.
Sir, I learned more about
Hmm.
the topic, like more deeply because I had to search in internet. No?
So the thing is that I'll tell you one thing. You gave some good points. So a teacher is just there to make a simple, difficult subject look easy and simple subject look more simpler. Rest studying is all self-study. Do you agree, Bhavna?
Yes, sir.
Until unless you don't study yourself, no teacher can give you like it's not a see in one class a professor's responsibility is just to take you to the ocean. Now it's about you how much you drink out from him or you leave it. So it's about you. Results in is in the hands of the students. Are you agreeing, Bhavna?
Yes, sir.
Yes. Okay. Ajit Kumar, you share your experience after this class. What you felt like compared to previously?
Yes,
Hmm. Tell me something. What you felt?
sir. I gathered information, sir. That's all. First time I have gathered this one information. Before I didn't do so.
That. But what about the subject? Did you learn something?
So subject, yeah, sir. I learned a little bit.
Okay, you get so according to you, the thing is that you feel like only you gathered in information from different sources and that's it. But what about your presentation and the skill level and the effort? Like how so many people are going to listen. Sometimes some people are very shy to speak out. It did not help you to overcome those hurdles.
Sir, le- yeah, sir.
No, no, no. You be outspoken in my class. If you are like, no, 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 it's a usual thing for me. I'm a RJ or something like that. It's nothing big time. You have to be yourself, okay? Not that because the some person is over here and you will speak. So speak out. Whatever you are, you have to speak out. Then only you will be acceptable and it will look good. Yeah, speak out yourself. Yeah, tell me some things because
Sir,
it's a mutual.
nothing.
Huh.
Nothing, sir. But from your drive link, I gathered more information, but I couldn't find so much, sir. So I took Google, sir. That's all.
Now, which drive link you gathered information? Where the
So
previous?
from your drive links.
Okay, okay. No, no, but we have. I have actually delivered this class. You can have. Even at YouTube also it is available, the information. If you see,
Yeah,
uh,
sir, but notes are
ma
not properly provided, so I took this.
okay, no, no, you are feeling the notes are not there.
Yeah, sir.
In which section the notes you did not find the notes?
Sir, in drive link only, sir. I took textbooks that Ranjini I took, sir.
In that you in the textbook, then the it's not there,
It's
magnetizing
there.
current.
It's
That's so.
it's there,
So
sir.
see, the thing is that I don't believe in spoon feeding. Okay, so if the student has to like learn, either see in my video lectures, isn't it there? Everything haven't I explained?
So you have explained, sir, but you should give time, no, sir.
Time in the
For
sense.
sir, 2 days, sir. Yesterday, we had festivals, sir. So only today morning only I finished this PPT, sir.
Okay, okay. So tomorrow, what will happen when you join a company? So you have some deadlines over there. So I'm preparing you for that. So
They'll
you
give you
can.
1 week time, no, sir.
And no, sometimes you have urgency. Like for my sister, they have, she has to give 100 test cases. Okay, every day she has to do 20 test cases. So sometimes deadlines are there. So you have to be under some pressure. Okay. So when there is some pressure, there is performance. Okay, if you don't give pressure 1 week time, okay, still time is it, time is it. You realize when there is an examination and you have only 2 days holiday for a subject, you will perform much better in that 2 day holiday subject than 10-day holiday subject. If I'm wrong, you just please tell me, isn't
No,
it?
sir.
Hmm?
Yes, sir. Yes, sir.
If you have less time, you'll study more. If
Yes,
you
sir.
have more time, you don't study. So this is human psychology. This is. So we know as a teachers, because directly I did not become a teacher. I was a student first. Okay, so I know. So that's the reason we are just trying to make out. So you cannot be relaxed. See, this is a time of competition. So many people are doing engineering and everything, and there is very less opportunities. So if we are to prepare the students, so we have to tell them the real story outside. We cannot tell them everything will be like in a silver spoon. Okay, so you have to fight for things. If you have to come and be good and be best, so you have to, like in my drive link, there are certain informations are there, certain informations are not there. I'll tell. No, no, but the lectures, whatever I'm presenting to you, everything is there. Moreover, the books that I shared with you, the Rajni book, other book, everything is there. So as a student, you should like strive yourself also. Okay. So that's my idea of teaching. See, notes means whatever I write, I can share it with you. Okay. I'm sharing also. But certain things means also have to work. Okay. Now, it was Ajit Kumar, Bhavna, Manohar. Yeah. You share your experience. Yeah.
Yes,
Tell me.
sir. I liked it a lot, and
Hmm.
it helped me get some gain. But I felt a little bad when I was not able to give the required info that,
Yeah. Where?
and that circuit diagrams explanation when this MMF stator course. It
No,
would have
no.
better if I would made some diagrams there.
No, no, that is a technical point of view. I'm talking about yourself. See, whatever you have delivered over here, it's for yourself, okay? Like
Yeah.
how you improved your understanding of the subject, and from the different sources you picked up the thing, and your insight into the subject, how it
It
affected
was
those
good,
things. Like Ajit
sir. When
Kumar
I
had his outspoken thing. I loved it. If I have to rate now, I'll rate Ajit Kumar at a better position, because he spoke certain
yeah.
things. Okay, he expects certain things from me. So, but I expect certain things from you also. Okay,
Yes, sir. I
so.
liked the YouTube videos, sir. When I was going through that magnetizing current calculation video, so I got the info from there. Then I referred your notes and which one you provided. Then I went through the textbooks.
See, my notes, there are so many notes, like IIT
Yeah.
professors are also delivering. So today there is a age of information. Okay, so information gathering is not a big thing. Like if you open a YouTube, If you go for a site, okay, there are so many sites, so many books scribbled, you can download so much material, okay.
Yeah, yeah.
But the thing is that after downloading the material, how you accumulate and
Yeah.
amalgamate different things, and how do you create uh,
Best out of it.
material and deliver it, that is
Yeah.
one challenging thing. And most important thing, for as a teacher's perspective, what I feel is that we as teachers should make complex things look simple. We should
Yes,
not
sir.
make, we should not complicate the things. That's all a teacher can do, okay. But rest of all is up to the students, how they are performing, if they are having any doubts. So whenever I'm
Yeah.
delivering class, what I feel is that you people are either shy, or you are getting everything, or you see, sometimes you have to ask, okay.
Yes, sir,
Sometimes
that's
what
true.
happens while teaching, what I feel is that in this medium, it becomes a little boring, okay. Online thing means, okay, some of you are hearing, some of you are not hearing, and it is very highly impossible to like hear this for 7 hours continuously, to sit in front of computer than in a classroom. I can understand this, but
Yes,
still
sir.
you have to pay some attention, at least the starting 15 minutes and the ending 15 minutes. Today, today's session, I thought of like we will cover we'll start with the synchronous machines. But
Okay.
what I feel is that let's do some quiz, okay. Just a quiz. I'll write some questions in the chat box. You give me answers. Huh? So let's see
Okay,
how
sir.
it goes. So it will be very interesting, and I'll rate you guys. Huh?
Okay, sir.
So let's have a competition. Okay. So it will be fun. Okay. Okay. You are able to see my this thing.
Yes, sir.
Yes, sir.
Okay. 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 Nice. Start. So the chat box, you have to give the answer. Yeah, wait. Right expression for bar current. These are the first four questions. So yes, the fifth question. So again, write an expression for bar current. So IB expression, I want you to write bar current. How do you write? Because you just now saw it. So if I give you the options, I will be able to answer. So that's why I'm not. So I want you to write this. Okay. What is the tau equal to? That is, tau is what? It is your pole pitch to your pole length. So what is it equal to? Okay, that one. What is Z? That is the total number of conductors equal to. And similarly, what is Z in terms of the number of turns equal to? This is the fourth question. This is the fifth question is, what is the average flux density equal to in terms of, so flux and the other parameters, that is BAV is equal to P phi L by pi, B is equal to BAV L phi by D, BAV is equal to P phi by pi D, D is BAV is equal to P phi by pi D. So let's see, this is the six questions. So are you answering this in the chat box? So yeah, please. So how many of you have started to answer? So the thing is that most of you are answering it. As if I see that the Afsa has answered one question. No, you cannot answer like this. Okay, answer every question like at a time. Afsa Firdos like one, two, three. No, when you have all the answers, okay, I'll clear the chat. Okay, so when you have all the answers, then only please answer at a time all the six. So only I can decide. Hmm? Okay, so I'll again show you the questions. So these are my questions. Write expression for bar current IB. What is tau equal to? Okay, what is Z total number of conductors equal to? What is Z total number in terms of number of turns equal to? Then you have what is BAV equal to? Okay, then There is question number 6. What is status slot pitch equal to? So these are my 6 questions. Again, I'll read it down. What right expression for bar current? So even though if you have answered, please answer all 6 at a time. So in the next 5 6 minutes, I'll evaluate and I'll rank people. Okay. Right expression for bar current IB. So we will like at 3 minutes I'll give 10:57. I'll close it down. So right expression for bar current. Again, you see this. What is tau equal to? What is Z? The total number of conductors equal to? What is Z total in terms of number of turns equal to? And then you have this, what is BAV equal to? What is status slot pitch equal to? So these are my questions. Again, you just have a look, all of you. So you answer it. Okay, Afsa has answered. Fifth and sixth is yet to be answered. Jyoti has answered. Okay, sixth, she's saying D. So Afsa, you got one wrong. Okay, so you got one wrong. That is the D option. So yeah. Aditya Vishwakarma. Now you cannot correct. Once you have done, it's done. Okay, Manohar. Ratika. Dikshita. Nilakshmi. Nivedita. Kancha. Kancha, you got second one wrong. See, most of you have given right answers. So, to be fair enough, we can have to see by time only who has given the fastest answer. So I'm just checking the time. As of now, Afsa has given very fast answers, but one of her answer is wrong. So she is the first person. Let me see. No. Fastest answer who's giving. So all six. Okay. That again 10:55 you have tried, but again it's wrong. Aditya Vishwa Karma. 10:56 a.m. 10:56 a.m. Okay. So Manohar M is first, okay, and second is Afsa Firdos. Although she gave initially wrong, but she has corrected. So followed by third, you have Ratika is there third. Then you have Navita Shri KS is also there, and you have Ratika is third because Ratika and Navita Shri KS. So Afsa and Manohar M. See, most of you have answered the questions right. So the question is write an expression for the bar current IB, which most of you have got right. What is tau equal to? That is pi d by p. What is this z equal to? That is the number of stator slots ZSS into SSS. This, what is this equal to? This is 6 times ZTS. And what is the expression for BAB? That is P5 by pi d. And what is the stator slot pitch? That is your pi d by SS. So if I have to write the names, so at 10:56, although Afsa answered it at 10:55, but only 5 questions. Then at 10:56, we see Manohar with the correct answer. Okay. Then simultaneously after that 10:56 point something, because Afsa initially answered, is Afsa one was wrong. Then at 10:57 we have Ratika, and similarly 10:57 we have Navita Shri KS. So this is how it goes. So how did you like the quiz? Yeah, tell me, Ratika. Yeah,
Yes, sir.
enjoyed it.
Yes, sir.
So this will bring something out of you. That's why I thought of presenting one quiz. So today's class we have hardly some 5 6 minutes left. So I'll wind it up here only, because synchronous machine is a new topic which we'll see tomorrow, because we are getting one extra class tomorrow at 1 due to that English class we'll be handling. So we have no problem. So please give your attendance, and I'll wind up this class. Okay. Stop recording.